Hey, okay, so a few of you asked me some questions about 5A, or B, C, or D, as well as 6. So this one is already solved for you up here. You have this on your key, but I just did this one. We're converting 3%, that's mass, to V, so that's going to be in grams per 100 mils, always, when you're dealing with percentages like this. And we're trying to get it to moles per liter. So if we set up this based on what it is describing, that 3 is really 3%. It's equal to the number of grams over the volume, which is 100 mils. And of course, because it's percentage, you have to multiply it by 100. Those two hundreds will cancel. The x, which is my unknown, becomes 3 grams. So now we want to convert it into moles per liter. Well, that's not so hard. We have 3 grams here. It's 3 grams in 0.1 of a liter, which is the same thing as 100 mils. That's what 3% M to V or W to V actually means. Then we are going to convert the grams into moles using molar mass. That's the molar mass of H2O2, which is hydrogen peroxide, right there. And once you do the multiplication, you end up with 0.88, multiplication and division, by the way, 0.88 moles per liter. Off we go. And 2 sig digs, that's all you can keep. Now, if you look at another one, let's do sodium chloride. That one's kind of funky. I'm just going to walk you through the setup, and you guys can finish it. I don't think it's going to be a bit of an issue here. So we have 26 is equal to, again, it's the same, W to V. So it's going to be X grams over 100 mils. So if you want to find, and of course you have to multiply it by 100. So this makes our calculation really easy. We end up basically with our grams being 26. Geez. So now what you want to do is you're going to take that 26 grams, which happens to be in 100 mils, which is the same thing as 0.1 liter. And we'll notice that, okay, this is in grams per liter. I want moles per liter. Haha, the rest is a piece of cake. You just pop the G's there, the moles on top, put a 1 there, get the molar mass of NaCl. You guys can do that, pop it there. These two will cancel, and then off you go. Find the answer. No biggie. No biggie, 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 biggie. Let's try 6A. Now, these are said to be tough, but they're not really. They're really quite straightforward. So what we're going to do is we're going to take a look at that 1.02 moles per liter, and we want to get it into percent grams per 100 mils, basically. So the first thing you're going to do is you're going to recognize that that's 0.02 moles per, what is this here? It's per liter, so now we'll get it into mils per 1,000 mils. No problemo. Guess what we're going to do now? Ha! We want to get rid of the moles. So this time, moles will go at the bottom. Grams will go up here. We need the molar mass of H2O2, which happens to be right there in our previous question. So I'll just steal it. We'll put a 1 there. We'll put a 34.04 there. Mole and mole will cancel. Hey, this is looking pretty good. We're then in G's over mils, which is exactly what I want. So if you do the calculation part, this works out to be 3.47%. And we're done. So you guys can do this. B is exactly the same as A, and this one here is really straightforward. Take a look at the key that's posted online. Hope that really helped you guys. Sorry it was a little bit longer than I anticipated, but I'm just getting used to this new technique. Have fun. Talk to you soon.